So this is question 6, duplicate elements of the CS88 Fall 2020 midterm. So let's look at the directions for duplicate elements. It says that you'll be building a recursive function that, given a list and a non-negative integer count, will return a new list with count duplicates of each item in list. So looking at the doc test and the structure of the function, we can see that indeed it does take in two elements, a list and count. And when you pass in, like for example here, a numbered list from 1 to 4, and you pass in count 3, what should be returned is a new list with each element repeated 3 times. So 1, 1, 1, 2, 2, 2, 3, 3, 4, 4, 4. Same thing with the second doc test. You pass in A, B, C, and 2. It should give you a new list of A, A, B, B, C, C. So we can actually draw this out to help us visualize how recursion might solve this problem. As a quick refresher on recursion, remember that recursion is solved by taking a larger problem and breaking it down into a smaller subproblem. In the context of our problem, we have a given list that we want each element to be repeated. So if we were to use the first doc test 1, 2, 3, 4, our larger problem is the list of 1, 2, 3, 4, right? And then a smaller subproblem might perhaps be a sublist. So let's actually go along with the idea and try to implement how we want duplicate elements to work. So we want every element to be repeated a certain amount of time. So in order to do that, what we can do is we can extract the first element, repeat that first element, and then pass the rest of the list into duplicate elements to do the same. Right, so we have here in this specific doc test, we have 1. We want to repeat it 3 times. It should give us a list of 1, 1, 1. And then we can't forget about the 2, 3, 4 because those have not been repeated yet. So we actually need to make sure we repeat those by passing it into the recursive function again. And it will do the same, takes out the first element, repeat it 3 times, and then passes it in the rest of the list. So you can see some kind of pattern here where it's doing the same thing over and over again, taking the first element, repeating it 3 times for this problem, and then recursive call on the rest of the list. So you'll eventually reach a point where you have hit the last element in the list and you have an empty list. And when you have an empty list, you don't have anything in there, right? Because if you take the length of this list, its length is 0, so there are no numbers for you to repeat, and essentially you don't need a recursive call anymore. Okay, so we can actually get some pretty valuable information from this diagram that we drew out. So let's try to find 3 pretty big things on pretty big things from this diagram that will help us build our recursive function. So first thing being the base case, right? Remember, base case is what tells you when, or it indicates when you should stop the recursion, right? So in our problem here, we stopped recursion once we hit this last part, right? Because everything up to here happened repetitive. Same thing, taking out the first element and then passing the rest of the list into the next recursive case. So we stopped that once we hit the last part where we have the list with a length of 0, essentially an empty list. With the empty list, there's nothing to repeat, so that's why we stop. So we just need to code that out. All right, so if the length of the list equals to 0, we return an empty list. Okay, so that is our base case. Base case is half of a recursive function. We also need to take care of the recursive part, right? So recursive part, remember, again, we need to figure out how we break down a larger problem into a smaller subproblem. And usually that's done by determining what we pass into the next recursive call. So you can actually figure that out by looking at this right side here where we have 1, 2, 3, 4. Next recursive call is on 2, 3, 4. Next recursive call is on 3, 4, 4, and then an empty list. Right. So you can see that we broke it down by taking out the first element and then taking the rest of the list. And the rest of the list is our next smaller subproblem that we have yet to solve. So in order to go from one case to the next case, what we actually did was we just extracted the first element, right? So how that would look like is just an indexing from 1 to the very end, okay? So that will tell the function to solve the next smaller subproblem. And actually, in our problem, we take two elements here. We take a list and a count. So we just need to make sure that we also have the correct value for count, right? So if we think about it, count, should it be changing between each recursive call? No, it shouldn't be changing because every element should be repeated the same amount of times. So it should just be the same original number that you pass in for count as count. It should be the same for every recursive call. Okay, so those are your two parameters or arguments that you'd be passing in for each recursive case of duplicate elements. So for the third part of a recursive function is now that you have broken down your problem into smaller subproblems, each smaller subproblem will give you a solution to that smaller subproblem. But you have this big list, 1, 2, 3, 4, that you want, where you want every element repeated. So it won't be good if you just have 4, 4, 4, 3, 3, 3, right? You want to make sure that you have all the elements repeated. So you need to figure out how you can accumulate the solutions to every smaller subproblem into a solution for a cohesive solution for the bigger problem. So in this case, for example, we have 1, 1, 1, right here, 1, 1, 1. The next recursive case after the 1, 1, 1 is actually the recursive call on 2, 3, 4. What that should return is 2, 2, 2, 3, 3, 3, 4, 4, 4, right? That looks like the solution that we want, but it's just broken up. So in order to kind of accumulate these smaller subproblems, all we need to do is to concatenate them, right? So we can see that in order to make sure that all your smaller subproblems give you, or all the solutions to your smaller subproblems are combined correctly, you just need to concatenate the two parts. So you have two parts, right? So here you can see the first part is list of first element repeated, right? And the second part, which is basically the rest of the list, list repeated. Okay. And then you want it to be concatenated at the very end. Okay, so that's kind of the outline you want to use to help you construct your code and try to see if you can implement it in this skeleton. So let's go ahead and try to implement it. So first thing we always want to start with, or you don't always have to start with the base case, but in our case, we already have a good idea of what the base case should look like. So our base case should be checking if the length of the list that's passed in is equal to 0. If it is 0, that means you have nothing to check and you just return an empty list, right? And so that's our base case. Now let's move on to the recursion part of a recursive function. So we can see number 2 and number 3 in here is what gives us a good idea of how a recursive part should look like. So we know that when we have a recursive call, it's going to be taking in these two parameters like this, right? And then we know we want our function to repeat the first elements and then call the rest, call the recursive function on the rest such that it will give us the list of the rest of the list repeated. And at the very end, we want to concatenate everything so it gives us a solution for the whole original list, right? So if we can look at the skeleton we have here, it kind of aligns with what we have, right? We have a first and a rest, right? So the first corresponds to the first element being repeated. So we can go ahead and put that where the first element is repeated. And remember, when you extract values from the list, you need to do access indexing, which will give you the number or just the direct element. So you need to make sure you put that in the list itself in order to do this times count where it's repeated. Okay. So that's first, and then you need to take care of rest. So rest is essentially the rest of the list, duplicated, which, as you can see from the skeleton code, is the recursive call. So we get duplicate elements, and what duplicate elements takes in from our number 2 right here is list from index 1 to the very end. And then count should not change because every element gets repeated the same amount of times. And finally, we have the return statement, right? So we essentially have everything down. We have the base case. We have the different parts of the recursive solution. We just need to make sure we combine the parts of the recursive solution together. So you just need to concatenate the first and the rest. Okay, and that is our solution to number 6, duplicate elements of the fall 2020 midterm.